All right, guys, are there any questions on any of the assignments thus far? What we're looking at today is solving systems of equations using determinants. So what we used yesterday and what we did yesterday, we're going to use those determinants to solve systems of equations. Now to do that, what we're going to do is set up several different matrices and take determinants of them. To find the value of x, we're going to take the system, so the values for a, b, m, f, g, n. So we take the matrix, the coefficients of this here, to make matrix C. So a, b, f, g, and that gives us c, the ones on bottom. To solve for x, we replace the x values with what it's equal to. Then we do the same thing with y and replace the y values with what it's equal to. And that will give us our solution. Now, this will make a little more sense once we actually do this here. So we have this system here. And we're wanting to solve for the value of x and the value of y. So our determinant, the matrix that's going to go on the bottom of each of these fractions, is the matrix that consists of the coefficients, the numbers in front of the x's and the y's. And it's going to be the same for both. So our values in front of x are 5 and 3. The numbers in front of y are -6 and 4. Now for the matrix, the determinant on top for x, we're going to keep the y values the same, so -6 and 4. But the x value is going to be what the equation is equal to. So for the top equation, it's equal to 15. So we replace its x value with 15. The second equation is equal to -29. So we replace its x value with -29. We do the same thing with y. But this time the x values are going to stay the same, 5 and 3. But the y values are now going to be 15 and -29. Now we just need to take the determinant of the top and bottom. Now the determinant of the numerators for x is again just going to be the diagonals. I do, but it'd take me a minute to get at it. Check back in about 20 minutes. So here, for x, we're going to take the diagonal, so 15 times 4 minus, going the other way, would be -6 times -29. In the denominator, we would have 5 times 4 minus, the diagonal going the other way would be -6 times 3. Big jam. Okay. Questions on this so far? Now at this point here, we could type this all into the calculator. Because if we wanted to, we could type the numerator, 15 times 4, minus -6 times -29. Yeah. Then we get -114. So it tells us that the numerator, x is equal to -114. We can do the same with the denominator. We can say 5 times 4 minus -6 times 3, which is 38. And then we can divide those and get -3. Or we could have typed that whole thing in to begin with, because we could have typed the entire fraction because we could have typed that whole thing into the calculator, hit enter, and it would have told us that it's -3. We didn't have to step it out. Questions on how we found the value of x? We can do the exact same thing with y. So we find the determinant of the numerator. So this time it's going to be 5 times -29. Minus, going the other direction, is 15 times 3. Yes? Over the determinant of the denominator, which is 38. Because those two are the same. We already found it. And we could type this in. Kramer. Five. Minus. If we type this into the calculator, we get a value of -5. So guys, so the solution for this is -3, -5. Questions on this here? We ready for the next one? Yeah. Okay. So this one here, we'll set it up first because I would suggest setting these up first before we type them in. Because this one here, we're going to do in the calculator. I'm going to show you how to do this one in the graphing calculator. And even doing them in the calculator is going to be good to set it up first. So we look at this here, the denominators, the determinant for the bottom of both of these fractions is going to be the coefficients of the numbers in front of the variables. So here, we'll have 7, 3, -5, -7. And it'll be the same for y. 7, 3, -5, -7. Now for the numerator, so since we're solving for x, we're replacing the x values with what the functions are equal to. So for the top number, we would have 37. For the bottom one, we would have -41. The y values would stay the same, 3 and -7. When we're solving for y, the x values are going to be the same, but the y values are going to be what it's equal to. So 37, -41. Yes. Yep. That's going to take a minute. Don't worry about it. I'll get it fixed later. How many different matrices do we have here? 3, because we have these two on top, because those are different, but the ones on bottom are the same. Now I labeled it A, B, and C because, again, when we use the graphing calculator, we need to input them in as a certain matrix. So we can call the top two A and B, and the bottom one C. So in the graphing calculator, clear all these out, we can start off by going second matrix and over to edit. And we'll put the numerator for x in first, 2 by 2. So we would have 37, 3, -41, -7. So this here is the numerator for x. Then we can go second matrix, over to edit, and this time we'll put in matrix B. So this would be for y. So we'd have 7, 37, negative 5, negative 41. So the numerator for y. And then we'll do this one more time. This time for the denominator, which is a 2 by 2. And this time we're just taking the coefficients. 7, 3, negative 5, negative 7. Any questions on how we type these three in? Now for the value of a, so we can go alpha y equals enter, because we have our fraction. Now we're going to take the determinant of a, so second matrix over determinant, second matrix a, over the determinant of c. So we can go second matrix, pull up determinant, second matrix c. Any questions on this so far? We hit enter one more time, and it tells us that the x value of this solution is 4. Questions on this here? Now we could go through and do the exact same thing again to call up determinant of a over determinant of c, but this time we're not talking about the determinant of a. We would actually need the determinant of b. So I can go up, select it, and replace a with b because we put it in. And it tells us that this is 3. Questions on how we did this here? So for our problem here, x is 4 and y was 3. Questions on how we got this here? Thank you. Any question on everything we've done so far? Now, we can also do this with a 3-variable system of equation. But the 3-variable system equation actually isn't any different than what we just did. The setup, all the steps are the exact same, but instead of having 2 by 2, we're going to have a 3 by 3. And if you notice with x, y, and z, they replace the x values when we're solving for x with what the equations are equal to. For y and z, they did the exact same thing. And for these here, because as we saw yesterday, taking the determinants of a 3 by 3 is a lot more challenging than a 2 by 2. It's going to be a little bit easier to do these in the calculator than to do them by hand. But in either case, I would highly suggest writing them out first, so that way we know we have the matrices set up correctly. In all three of these cases, the denominators are going to be the exact same. It's just going to be the coefficients of our variables. Because the denominator is just like with the first one. It's just going to be the determinant of the numbers in front of the variables, our matrices. Now for x, the numbers for y, 5, negative 2, negative 6, and z, negative 6, 7, negative 8, are going to stay the same. But the x values are going to be what it's equal to. So negative 14, 47, and 15. For y, we're going to make the y values negative 14, 47, and 15. But the x values, 4, 3, 7, and the z, negative 6, 7, negative 8, are going to stay the same. And for z, this time we're going to change the z values. So negative 14, 47, and 15. But the x value is 4, 3, 7, and 5, -2, -6. The x and y values will stay the same. Questions on how we set these up? But this time, how many matrices do we have? 4, because we have 3 for just the numerators, and then we have 1 for the denominator. So at this point here, we can set these in. So we can plug in A, B, C, and then matrix D. I put a letter next to it just to remind myself which matrix is assigned to which one. So we go second matrix, over to edit. But this time we're going to have a 3 by 3, which is going to be -14, 5, -6, 47, -2, 7, 15, -6, -8. So we'll type the first one in. Then we can go second quit, second matrix, over to edit, and plug in matrix B, which is for the numerator of y, which will be 4, -14, -6, 3, 47, 7, 7, 15, -8. Second quit, second matrix. Now we're going to edit matrix C, which will be the numerator for the solution for Z, which again is a 3 by 3. So we'd have 4, 5, -14, 3, -2, 47, 7, -6, 15. Now we have one more matrix to plug in, which is going to be matrix D, which is just the original matrix. So 4, 5, -6, 3, -2, 7, 7, -6, -8. Just like with the last one, we could go up and select this here, determinant of B over determinant of C, but that wouldn't give us the right answer, because the new determinant for the denominator is not matrix C anymore. It's what? Matrix D. So I can come back up here and replace matrix C with matrix D. And in the numerator, we'll replace matrix B with matrix A. So if we take the determinant of A over the determinant of D, we get the x value, which is 5. So the x value of this is 5. Now to find the y value, we can go up and select this again. And this time replacing matrix A with matrix B. And it tells us the y value is -2. Now we need to do this one more time. For this time we're replacing matrix B with matrix C. And it tells us the z value is 4. Bless you. So our solution for this here is 5, -2, 4. Questions on this here? I mean, it's a lot of steps to do, but luckily the calculator will help you with pretty much all of it. And that's it. You have a total of 4 problems.
That's it.
Mm-hmm.
Are you still about where it's yeah, I feel like yeah.